Part two. So average rate of change, as soon as you see this question, think back to the formula for average rate of change, which is y2 minus y1 over x2 minus x1. So now we just need to figure out what that is. So hours of daylight per month from January 1st, okay, until April 1st, okay. So here we go. So this is the, if you take a look at it, April is the 4th month, January is the 1st month. So here's your x values and here's your y values, okay? And now all we have to do is plug it in. So we have y2, so 13.9 minus y1, which is 9.4, divided by x2, which is 4, minus 1. And you plug it into a calculator, hit enter, and you're going to get 1.5. So what is the average rate of change? 1.5 hours of daylight. So it says, that's the answer to part A. Interpret what this means in context of the problem. Okay. So it means that the average rate of change, um, in the number of months, number of, actually hours of daylight from January 1st to April 1st is 1.5 hours. Okay, that's basically what you need to write. Something like that. All right. Algebraically solve for x. So since it says algebraically, you cannot use a calculator. You can use a calculator to check your answers, but not to actually do it. Just to refresh your memory, to check, you plug this under y1, right side under y2, and see where they intersect. So first thing we need to do is find our least common denominator. So we have our least common denominator. We have 2x, then we have x plus 1, and we have 4. So 4x parentheses x plus 1 is going to be our least common denominator. So you have to get all of them to be that denominator. So to get this to be 4x parentheses x plus 1, we need to multiply it by 2 to get it to be the 4x, and then we need to multiply it by x plus 1. And then whatever you do to the bottom, you do to the top, x plus 1. And then this is already has the x plus 1, it's missing the 4x, so we have to multiply bottom and top by 4x. And the last one is missing an x as well as a x plus 1, and we have to do that to the top as well, x plus 1. And once you get the denominators to be the same, the red marker can come out, or the color, and then you just need to simplify it. So 7 times 2 is 14. So I have 14 parentheses x plus 1. I don't know what's going on with my x's today. Then I have a minus 2 times 4x, which is 8x, is equal to x parentheses x plus 1, because 1 times anything is itself. And then I need to just simplify this to see what it gives me. So I have 14x plus 14 minus 8x is equal to x squared plus x. Okay, we're in good shape right now. So then I just need to solve. So 14x minus 8x is 6x. And then I have plus 14 is equal to x squared plus x. So I'm going to move everything to one side. So minus 6x, and minus 14, minus 14. So this cancels out, and I'm left with x squared minus 5x minus 14 equals 0. AM method comes in handy here. So two numbers that add to be negative 5 and multiply to be negative 14. So 7 and 2. So x minus 7 and x plus 2 equals 0. I just need to switch the signs, so I get x is equal to 7 or negative 2. And then I need to check it by plugging it back in. And if I do that, none of these denominators are going to give me 0, by plugging a 7 here. That's not going to give me a 0. Plug in 7. That's valid. Plug in -2. That also gives me valid answers. So both of my answers are valid to go. All right. Next one, I'm going to just go ahead to my calculator, plug in what I'm given. So I'm just going to go turn it on. I reset my calculator since last time, so everything is like new. So I have to get the log. This cannot give me the base, so I have to hit math, go down to log base, hit enter. I gotta put the 2 in there, and then I put x plus 6. So x plus 6. And then all I have to do is hit second and go to my graph so I can see what points I'm gonna plot. So I see 2, 3. So 2, here's 2 right here, 3 is right here. So I'm gonna go to where they meet. So that's, it helps to point the ones that are like whole numbers, 10, 4. So I'm gonna go back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. So right there, and then I'm gonna go ahead and see a couple of more points. So let's go ahead and scroll down. So -2, 2, -2, 1, 2. That's another point that I can graph. Let's see if here's some more. -5, 0. So -2, -3, -4, -5, 0. Right there. -4, 1, which is right here. And then I'm just going to go ahead and plot these points. And when you plot them, you want to make sure that you are as accurate as possible. Like that. And then you also need to make sure that you understand that from here we're going to go down, like the curve decreases. Should draw this a little bit better. It's going to go something like this, right? Okay. And now I've graphed. Okay. You want to put arrows on the end of the line, and you want to make sure that your log graph keeps on going down. Okay. So the next one, given tangent is equal to 7 over 24. So we're in quadrant 3, which means that we're right over here somewhere. So I'm going to draw my right triangle right from it. So here's my theta. So theta terminates in quadrant 3. So boom, tangent of theta is equal to 7 over 24. So just to refresh your memory, ka, toa, right? Toa stands for opposite over adjacent. So I'm going to do that. So I'm going to go over here. I'm going to go opposite it right here. And I'm going to put a 7 because my opposite number is 7. And then adjacent, which means right next to, which is this right here. Here's my adjacent side. So I'm going to put a 24 there. I know that this is negative 24, and since I'm going down here, this is -7. So -7 over 24. And then I need to find my value of cosine. So this is what it's asking me to find. So cosine of theta is equal to, right, I'm looking to see what that's equal to. So I'm going to go ahead and cosine is equal to adjacent over hypotenuse. So I have my adjacent side already. It's going to be -24. It's right here. So I put -24 over, and I need to find my hypotenuse. So to do that, I need to do quadratic formula. So I have -7, right? A squared plus b squared, which is -24 squared, is equal to my hypotenuse squared. So hyp squared. So I solve all of this, blah, 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 and I'm going to get h is equal to 25. So solve it, and you'll see that you get 25. Let me know if you get stuck as to how to do that. So you have -24 over 25 as my final answer for cosine. And I know that cosine has to be negative because in third quadrant, my signs are negative, comma, negative, and cosine is negative. Okay? Question 29. So Kenzie believes that for x is greater than or equal to 0, the expression blah, blah, blah. So I'm going to go ahead and put this into a different form. So here's my 7 is my root, 2 is my exponent, so that's going to go on the top, multiplied by x. My 5 is my root, and 3 is my exponent. And she's saying that it's equivalent to x to the 35 is my root because the number that's here, and then 6 is my exponent. So let's see if she's right. Okay, when you're multiplying, you take these exponents right here. We're going to take this, and we're going to add them. So let's go to our calculator, because who remembers how to add fractions? Not a lot of us. So I go alpha y equals option number 1. So I'm going to put 2 over 3, and I'm going to put plus, and I'm going to do another fraction. Alpha y equals option number 1. So I'm going to put 3 over 5, hit enter, and boom, I have 19 over 15. Okay, so 19 over 15. So we're going to see if that is correct. Did I just, 2 over 7. Okay, we're good. So we have on our calculator, we have x to the 19 over 15, and she's saying that it's equal to x to the 6 over 35. They are not the same. These two are not the same. So no, she is not the same. She is not correct. You want to definitely make sure that you say no. And you could even say like, because 19 over 15 does not equal 6 over 35. Okay. Okay, so I just realized that I did not plug in 2 over 7. I plugged in 2 over 3. So I went back and I fixed it. Look at that. Look at me checking my work. So I have 31 over 35. So I'm going to go back over here, and still, regardless, my answer is still the same, but I want to show my work correctly. So 31 over 30. Come on. 31 over 35 is not equal to 6 over 35, and I want to write that down. Okay, so because 31 over 35 does not equal 6 over 35. There we go. All right, let's move on. So question number 30, when the function p of x is divided by x minus 1, so I have x minus 1 here, I'm dividing by p of x, so I don't know what that is. It's telling me that the quotient is x squared plus 7, and then we have a remainder of 5. Remainder of 5, right? Because the x minus 1 is whatever just goes on the bottom. So I want to figure out what the actual number is. So to do that, um, okay, so if I had a separate problem like this, if I said, okay, I know my answer is 5, uh, the number right here is 2. I know that I have to multiply these two, which is 10. And then if I had a remainder of, let's just say 1, then that would be 10 plus 1, which means that I would have an actual number 11 here, right? That makes sense. 2 goes into 11 5 times, remainder 1. So this is just like a simple problem to kind of help me understand what to do here. So I'm going to have to take these two here, and I have to multiply it and then add 5. Add my remainder to figure out what goes inside this parentheses, or in this division symbol. So let's do that. X squared plus 7 times x minus 1, and then I have to remember to add 5 at the end. So let's go ahead and do that. X to the third, that's negative x squared. This is plus 7x, and this is minus 7. And I have to that, I have to add 5 plus 5 to it from here to just bring this down. And so now I'm going to combine like terms. So I have x to the third minus x squared plus 7x. And negative 7 plus 5 is negative 2. And this is what p of x would be. So p of x in standard form, and boom, there's standard form. Okay, it's question number 30. Write a recursive formula So recursive just means what am I doing to the previous number to get the next number. And here I can see that, so I might think that I'm adding 3, but then that's not consistent. So I know it's not going to be adding, so it has to be geometric instead of arithmetic. So to figure out what that number is, I can take the second number, which is 9, divided by the first number, which is 6. And 9 divided by 6 is equal to 1.5. 1.5. So I think my pattern is multiplied by 1.5, and I can check it. 9 times 1.5, boom, is 13.5. So we're good. So my recursive series or sequence is going to be A1. I have to state what my first term is. So my A1 is 6. Boom. So I have that. And then to get every other term after that, I do times 1.5. So I do an minus 1, which is I take my previous term, and I'm going to keep on multiplying by 1.5. Multiplied by 1.5. And right there is my recursive sequence formula. Okay? Question 32. So do the results of this simulation provide enough evidence? So this is very similar to what we did with the 95%. So it says strong evidence is like 95%. So to do that, you'll have to do mean plus or minus 2 times the standard deviation. See, there's 2 questions like this. So let's do that. So the mean is 0.499 plus or minus 2 times our standard deviation, which in this case our standard deviation is times 0.049. So now I need to figure out what my interval is. So if I do 0.4099 minus 2 times 0.049, you should do this yourself. You should get 0.401. And if I do 0.499 plus 2 times 0.049, I get 0.597. So this is my interval. So she flipped 43 times, heads 43 times out of 100. So 43 out of 100 is 0.43. That's 43%. And I can see that 0.43 is between 0.40 and 0.60 almost. So 0.43 is here. So do the results of this simulation provide strong enough evidence? And you could say then in looking at it, um, 0.3 is between here, so it's fair. It's not unfair. So do the results of the simulation provide strong enough evidence that Robin's coin is unfair? The correct answer is no, it is not unfair. Since 0.43 is between the interval, Robin's coin is likely not unfair, which means that it's fair. Okay? So you want to write something like that for this answer. All right, moving on. We're almost done. Question 33. So we're going to factor this completely. So in order to do that, we're going to go ahead and break this down. This is a perfect square. This is a perfect square. So I can break this down into the square root of 16 is 4. Square root of x to the 4th is x squared. So I'm going to put that in the other one as well. 4x squared. This is 81, so square root of 81 is 9. One's a positive, one's a negative. It says factor completely, so it's actually giving me a hint that I can factor further. So this 4x squared plus 9, since there's a plus, you're going to leave that alone. I'm just going to write that down again, 4x squared plus 9. But this one can also be factored down again, square root, square root. So this is going to be another double bubble, 2x plus 3 minus 3. Okay? And that is factored down as much as possible, so I'm done. Sarah graphed the polynomial, and stated all the roots of this are real. is she correct? So to do that, let's go ahead and solve. So 4x squared plus 9, roots are real, so we're going to set it equal to 0. So we're going to do minus 9 minus 9. So we get 4x squared is equal to negative 9. And I can tell right now that it's not going to be, but let me just finish this so you can see why I'm saying that. So x squared is equal to negative 9 over 4. So I'm going to do the square root, and so I'm going to get x is equal to positive negative, and boom, I have a negative sign under the radical, which means that I'm going to get an I, which means imaginary, not real, and I'm going to have 3 over 2. So x equals positive negative 3 over 2i. Is Sarah correct? So we're going to say no. Uh, I'm going to leave a little bit of space. 3 over 2i are roots. And the reason why I'm going to leave a little bit of space is so I can put the plus or minus sign. Right? These are roots. So they are not real, those are imaginary. The other roots right here, if you set these equal to 0, they are going to be real, but if you have two of them that are not real, then she's not completely correct. Okay. Question 34. So half-life of a radioactive substance is 15 years. Okay, so I know that right here I have an important piece of information. Write an equation that can be used to determine the amount of 200 grams of the substance that remains. So we're starting with 200, so that's going to be our amount that we're beginning with. So S of t, is equal to 200, which is the amount that we're beginning with. It is a half-life, so our rate is going to be 1/2. And then it's going to be time, so it's going to be t, but the half-life is 15 years, so we're taking this t and we're dividing it by 15. Okay, because it's happening, it becomes half the amount every 15 years, so you're taking the t and dividing it by 15. Okay, determine algebraically to the nearest year how long it's going to take for it to get to 1/10 of it. So that means that this right here is going to be 1/10. So I'm going to go 1 over 10 and is equal to 200 times, oh, so 1/10 for it to remain. So it doesn't really matter how much we're starting with. The 200 doesn't really matter. So we could even just ignore that, and go like 0.5 or 1/2 to the t over 15, and we have to solve this. Okay, determine algebraically, so we can't just use our calculator and put this under y1 and put this under y2. We actually have to solve. So when I have a question that looks like this, and I'm looking for my exponent, which is t, I'm looking for this right here. So I know I'm going to have to use log. So I'm going to go log. This number right here is my base. Here's my base, so I'm going to put my 1/2 right here. I could put 0.5 if I wanted to. Is equal to the answer to, I'm going to put the equal sign over here. The answer to a log is our exponent. So this right here, which is t over 15, is going to be the answer to my log. And then I'm going to put my 1 over 10, which is this number right here. That's going to go right there. And I'm going to solve this to figure out what my t is. So my final answer is going to be t over 15. So I want to get the 15 by itself. All of this I could just plug it into my calculator. So let's just go ahead and do that. So I'm going to take my calculator, turn it on, clear what's there. So I have log with a base of 1/2. So I'm going to hit math, go up to log base. For convenience sake, I'm just going to put 0.5. And I have 1 over 10. So 1 divided by 10 right here. And that's going to give me the answer for t over 15. And I have to multiply it by 15 for both sides, so times 15, and I'm going to get about 49.828, and it says rounded to the nearest year, so t is going to be about 50 years. Okay, about 50 years is how long it's going to take. Okay. Next, so we have 35. So focus of 4, -1. So I'm gonna first thing we're gonna do is we're gonna draw it. So we're gonna go like these. Forgive my x and y coordinates. So I have 4, -1. So 1, 2, 3, 4. -1 is going to be my focus. My directrix is going to be y equals -5. -1, -2, -3, -4, -5. So right here is going to be my directrix. Reminder, to get the vertex, you have to go halfway. So this number right here is my vertex. So this is going to be at 4 comma. This is -1, -2, -3. So 4 comma -3 is going to be where my vertex is. And then I know that my parabola is going to, it can never cross my directrix. So it's going to be facing up like this. So I look at to see what my P is. So my P is this distance right here, which is P is equal to 2. So then I plug it into my little formula. Okay, so the formula is x minus h squared is equal to 4p times y minus k. So I'm going to take my answer. Here's my h, here's my k. I'm going to switch the sign. So this is positive 4. I'm going to do x minus 4 squared is equal to 4 times, since my parabola is positive, it's going to be 4 times 2. Y, and this is -3, so I'm going to switch that. So that's going to be plus 3. 4 times 2 is 8 times y plus 3, uh, x minus 4 squared. Since it's not telling me to do anything with this, I could technically leave it like this, but I'm not going to because I'm the teacher. So I'm going to divide both sides by 8. So boom. So I have x minus 4 squared over 8 is equal to y plus 3. Subtract 3 from both sides, and my final answer is going to be x minus 4 squared divided by 8 minus 3 is equal to y. So here's my equation of my parabola. Okay, that's question 35. Question 36. So we haven't really done this a lot. We haven't done this at all, really. But probability. So it says, given, this is going to be a quick lesson right now. So given that the practice time was long, so long practice time, determine the exact probability that Felipe wins the next match. So this is going to be a probability question, and like I said, we haven't really touched this that much, so you're going to pick up what you can right now. So we're looking for the probability that Felipe wins the next match, that he wins, given, so the symbol for given is a line, that the practice time was long. So a long practice time. The formula for a given is going to be the probability of both um, Felipe winning and long practice time divided by whatever the second one is. So the probability of long practice time. Okay, so to do that, all you do is you look and see Felipe and long. So Felipe and long. Let me just show you how to do that. So Felipe is here and long is right here. Where do they meet? Boom, they meet right here at 12. So 12 is going to go at the top, and it's going to be over the probability of long. So to get that, we're going to take all our longs. So here's our longs right here, and we're just going to add these up. So 15 plus 12 is equal to 27. So there's going to be a 27 on the bottom. Okay, so 12 over 27 is going to be my answer. And then it says determine whether or not the two events, whether he wins and long practice time, are independent. So to tell if something is independent, what you want to do is we want to see if the probability that Felipe wins given long practice time, we want to see if that's equal to the probability of one of them, right? So the probability of Felipe winning. So this is what we do. We look to see what is the probability of Felipe winning. Okay, so Felipe can win. Let's go back to our table. Felipe, let me just go ahead and get this out. Felipe wins uh, here 10 here with a short practice time and 12 with a long practice time. So that means that he wins 22. So this is going to be 22 out of 45 trials altogether. Where am I getting 45 from, right? If you take all these numbers right here and you add them up, you get 45. So 22 out of 45 is the number of times or the chances that Felipe wins. Um, so we have the probability of F given L already, 12 over 27, and you have to see, are these two the same? Are they equivalent? So 12 over 27, we have to see if that's equal. So this is a straight calculator question, so turn this calculator on. 12 divided by 27, hit enter. We get 0.44444. So we have to see, is 0.44 equal to 22 over 45. So 22 divided by 45, hit enter, 0.4888. So 0.4888, right? I did that wrong. 0.4888. These are not the same thing, so no, they are not the same thing. So you say if they're different, they are dependent. They are different, they are dependent. So these two numbers are different. So you would say since the probability of Felipe winning given there are long practices does not equal the probability of Felipe winning, the events are not independent. Independent. Okay, I'm gonna abbreviate. All right. Our last question, right? This is our last question. Woohoo! So it says blah 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 blah. You can all figure this out. So this one we have done. So the period is equal to, I want to refresh your memory, 2 pi over b. The b is the number that's in front of, in this case, our variable, which is t. So we're going to go 2 pi over 0.8 pi. And then we just need to simplify this. So the pi's cancel out. 2 divided by 0.8. Let's just go ahead and do that in the calculator. 2 divided by 0.8. I said 0.8. 0.8. Thank you. Is equal to 2.5. So our period is equal to 2.5. Okay. That's how long it takes. So interpret what the period represents in this context. So what that means is this is talking about a wheel. So it just means that the wheel rotates every 2.5. And what's our unit? Oh, time in seconds. Okay, in seconds. So this is going to be the wheel rotates every 2.5 seconds is what we can interpret from the period. Okay. And then it says on the grid below, graph at least one cycle of f of t that includes the y-intercept of the function. So we're going to take our calculator right here. I'm going to hit the mode. I'm going to make sure it's in radians, which it is, and we're going to go ahead and plug in our formula. So we have our formula, which is given to us, which is negative 13, and then we're going to do cosine. Parentheses opens up for us, so we have 0.8 pi. And I know I could have stopped the video to just do this myself, but some of you might not know where things are, so I just think it's good practice. And then we go ahead and just graph it, and we're going to get something that looks like this. Okay. So it says graph at least one cycle that includes the y-intercept. So I can see things that are happening up here, right? So I'm going to go ahead and change my window so that I can see it. So I'm going to go to my Y max right here. It's my Y max, and let me be a little bit dramatic and just put 30. Okay. And then let me go ahead and hit graph, and it just wants one cycle including the y-intercept. So I'm just gonna see where it crosses, and look, crosses right here. Looks like it crosses right at 0, 0, and I can go to my table to verify that that's true. So 0, 0, boom, right there. So I'm gonna go ahead and put a point right here. Let's just say I go every, see how to graph it. If I go every 5 and put a 1, 1, 2, 3, 4, 5. Here's 1, 1, 2, 3, 4, 5. There's 2, 1, 2, 3, 4, 5, and there's 3. And I know that my tallest number that I'm graphing looks like it's like 23 point something. So I could go every like 10. So 1, 2, 3, 4, 5, and I'll put a 10 right there. 1, 2, 3, 4, 5. This is going to be another 10, which is 20. 1, 2, 3, 4, 5, and this is 30. All right, good so far. And then I'm going to go ahead and just plot. So 0, 0, I already plotted that. 5, 0. Okay, so it comes back down there. Okay. So it looks like I'm just going to go ahead and plot. So I have at 1, I have about 23. So I'm going to go to about 1 and go to about 23. So this is 22, 4, 6, 8, 10. So 23 is going to be somewhere around here. And then I look and I go, okay, to see where the rest of it is. I know I'm going to have to be symmetrical at some point. So I have uh, 123, 2, about 9. So I'm going to go 2, about 9, about there. Okay. And so I know I'm going to have a graph. So let's go ahead and match this a little bit better. So let's go to my window. Let's just say my x min, move this right here, is 0. My x max, the highest number that I'm going to, is around 3. My y min, I'm going to go ahead and change this to 0 so I can make it look like my graph right here. My y max is 30. So now I have something better to graph. It looks like it's going like that, and then down. Okay, I could do that. So I want to find out what this height point right there is. So I'm going to go second calc, and I'm going to go to maximum, which is option number 4. It's going to ask me to go a little bit to the left of that point. So I'm going to keep hitting left. Why does it keep disappearing? Stop disappearing on me. Okay, left. So I'm going to go a little bit to the left of the point. I'm going to hit enter. Right means that I'm going to keep going to the right of where the maximum is, and I'm going to hit enter somewhere around there, and I'm going to go where I think the maximum is, just somewhere around there, and I'm going to let my calculator tell me where it is. So 1.25 is going to be my max at 26. So 1.25, okay, it's around there, and 26. So 20, 20, 22, 24, 26. Okay, so somewhere around there is going to be my highest point. So I'm going to go ahead and now sketch it. So it's going to look something like this. It's going to be curved. I know it's going to come down and hit this point right here. Okay, and then I'm going to see where over here is where this is 3, so it's going to be about around like 2.5 or so. I'm just going to curve this out like this. Okay, so I drew at least one cycle, which is what they asked me to do. And then it says, does the height of the nail ever reach 30 inches above the ground? So this is where 30 is. So the answer is going to be no, it does not. So no, because, hey, come on, because the maximum of f of t of our function is 26. It's about 26 is the height, right? Uh, just make sure that this is all good. It is f of t, right? Yep. Okay, perfect. So we just graphed it and we're done. Good job.